Hello, in this video, we will see what are the objectives of experimental research and which are the various types of experimental research. The question was like this: what is the objective of experimental research design? Explain different types of true experimental research design. 2016 June question. And then differentiate between true experimental and quasi experimental design. Illustrate any one of the true experimental design. It was from 2018 December question paper. Experimental design is the process of carrying out research in an objective and controlled fashion. Highly controlled fashion, we are conducting the experiment here, so that the precision is maximized and specific conclusion can be drawn regarding a hypothesis statements. We are testing a hypothesis systematically. Now let us see what are the objectives of experimental research design. Generally, the purpose is to establish the cause and effect relationship between the independent variable and the dependent variable. The goal of experimental research is to provide more definite conclusion about the causal relationship among the variables in a research hypothesis than what is available from the correlational research. Here a researcher get a definite conclusion and a more clear picture on the cause and effect relationship of the variables. Now let us see the true experimental research. Experimental research we can divide it into three types, that is true experimental research, quasi experimental research and correlational research. In true experimental research, it is often considered as the most accurate one. Out of these three, most accurate one is true experimental research, because in true experimental research, researcher has a greater control, and so that he can control the possible errors that occur in between the experiment. True experimental research is a statistical approach to establish the cause and effect relationship between different variables. There are three criteria that need to be met in order to carry out the research design. If it is a true experimental research design, there are three criteria they should follow. Now let us see what are these three criteria. First one is the existence of a control group. There should be an experimental group and a control group. Control group is the group in which we are not doing any special treatment. We are keeping it as such. The next criteria is that the presence of an independent variable, because in the experimental research we are just checking the effect of independent variable on the dependent variable. Third one is random assignment. What we are doing here we are selecting the participants randomly. Participant must be randomly distributed within the group. Example, the researcher may be interested in comparing the self-instructional method with the conventional method in terms of achievement of 9th grade students in science. This is an example for true experimental design. So how we can allot the groups and how we can conduct the experiment. Let us see that. In order to pursue this objective, the researcher may randomly make two groups of students. Before proceeding to the formulation of the group, he will try to find out those variables that may influence the achievement of the students irrespective of the method of teaching. There are many other variables that also will affect the achievement, not only the method of teaching, that the researcher has to find out first. These variables can be intelligence, motivation, socioeconomic status, previous achievement in the science subject, etc. The researcher will equate these groups of students on these variables and randomly assign students to the group. If the mean score of the students on this variable is computed, and it will be found that means of two groups will not differ significantly. That means the two groups are equated on the above mentioned intervening variable. For example, the researcher will select the subject in such a way that the subjects or students from the same socioeconomic background and uniform intelligence and uniform motivation as much as possible. Now let us see which are the different types of true experimental studies. There are four types of true experimental studies. It is based on the formation of the groups and the ways of conducting the test. The first one is pre-test post-test control group design or randomized control pre-test post-test design. Here we can see a pre-test, that is before the treatment we are giving the test, and post-test after the treatment we are giving the test, and there is a control group, so that it got the name pre-test post-test control group design. After the formation of group by selecting the subject randomly, the researcher will administer the achievement test to the students of both the groups. Here the researcher first select the subjects randomly and made two groups, and he will administer the pre-test or an achievement test in both the group. Why it is called the pre-test? Before giving any treatment he is giving the test. The pre-test scores will reveal the initial differences, if any, with respect to the achievement of the students in both the groups. After this, the researcher randomly expose one of the group to self-instructional method. Here also he is selecting the group randomly. Out of the two groups, he select one and give self-instructional method and the other one with conventional method. The content of the teaching and time of exposure of both the groups remain the same. At the end of the treatment, both the groups are administered with same achievement test. So this is after the treatment, so we can call it as a post-test. The scores obtained are called post-test scores. In this way, the dependent variable, that is achievement we are measuring here, has been measured before and after the treatment in randomized equivalent group. Here randomly he is selecting the group, randomly he is giving the treatment, and later on he will measure the achievement. So in short, we can see the various steps of pre-test, post-test control group design. What is step 1? Form two groups by selecting the subject randomly. There are two groups, one experimental group and one control group, and here we are selecting the subject randomly. Then step 2, both the groups are administered with same achievement test as pre-test. Here same achievement test is administered in both the groups as pre-test. Then the experimental score these pre-test and keep these scores in order to compare with the post-test score, isn't it? So that then next step is treatments are randomly assigned to the group. One group get the self-instructional method. So self-instructional method is the special treatment here, so that here onwards this group we call it as experimental group. The other group got the conventional method. That group is called the controlled group. Then in step 4, we are administering the same achievement test as post-test in both the groups and then score them. Then later on in step 5, find out the mean score of the pre-test and post-test. Then check the difference between the mean of pre-test and post-test in order to find out, or in order to ascertain that whether the experimental treatment produced any significant effects or not. Next type of true experimental design is post-test only control group design. Here the researcher is conducting only one test, that is post-test, only after the treatment. Step 1, make two groups by selecting the subject randomly from the population. Here also the experimenter is selecting the subject randomly. Then in step 2, select one group randomly and keep it as a control group and other as an experimental group. Then step 3, here there is no pre-test, and then the experimental group is exposed to the self-instructional method and the control group with the conventional method. In step 4, at the end of the treatment, same achievement test is administered on both the groups, and these scores are called post-test scores. Then in step 5, find out the mean value of the post-test scores of both the groups, and they are compared in order to find out the effect of this independent variable on the dependent variable, that is the achievement. This is post-test only control group design. Next one is Solomon's 4-group design. Here there are 4 groups. One is taken as an experimental group and other 3 as control groups. In step 1, the researcher formed 4 equated groups by randomly assigning subject in all the 4 groups. There are four groups A, B, C and D. In step 2, out of these four groups, any two groups are randomly selected and pretest is administered. Here pretest is administered only in two groups out of the four. That also the researcher will select us randomly. So that let us see the group A and C are received the achievement test, the pretest. In step 3, out of these four groups, one pretested group and one unpretested group, maybe group A and B. A got pretest but B doesn't get any pretest. The researcher select these two groups A and B and give the treatment, that is the self-instruction method. The remaining two groups, that is C and D, one pretested and one unpretested group, are exposed to conventional method. Time and duration of the test are same as before in both the groups. Then what is the next step? At the end of the treatment, all the four groups are administered with the same achievement test. The scores are called post-test scores. Here, after the treatment, post-treatment, isn't it? So it is called post-test. And then all the four groups are administered with the same achievement test and we are calculating the scores. In step 5, mean post scores of all the four groups are compared in order to ascertain the experimental treatment produce significant effect on the dependent variable, that is achievement. Then group A, that is pretested group that receives the self-instructional method, is known as experimental group. All other groups are called control group C1, C2 and C3. It can be inferred that main feature of pretest post-test control group design and post-test only control group design are simultaneously present in Solomon's four group design. That we can see that the Solomon four group design got all the characteristic of above two tests. That is, which are the tests? The pre-test, post-test control group design and at the same time the post-test only control group design. All these characters we can see in Solomon four group experiment. This design is valid against the criteria of internal validity like history, maturation, testing, instrumentation, regression, selection, mortality, etc. All these can affect the internal validity of a test. Then the findings obtained by applying this design can be generalized to the population as it is extremely valid against the interaction of testing and treatment criterion. Here the test result is valid so that we can make the generalization very easily. Next one is factorial design. A factorial design enables the researcher to manipulate two or more variables simultaneously. Earlier three types of true experimental design, we are manipulating only one independent variable. Here in factorial design, the researcher is manipulating two or more variables simultaneously in order to study the effect of number of independent variables singly as well as the effect due to the interaction with each other. So the interactive effect, and they wanted to study the separate effect of the independent variable. So that here the researcher is manipulating two or more independent variable at a time. The design include two or more independent variable and each one is manipulated two or more ways to assess both their separate and combined effect. That is called the factorial design. Let us see an example. Here the researcher take the method of study, achievement, motivation and intelligence, all three as independent variable. All these independent variable has an effect on the achievement of the student. So achievement of the student is the dependent variable. Then here the researcher is dividing intelligence into two heads that are high intelligence group and low intelligence group. Again the achievement motivation also divided into two groups, high motivation and low motivation. Then method of teaching us discussion method, demonstration method and lecture method. So here each independent variable has different level or factors, so called factorial design. In such situation, the researcher take an institution and administer an intelligence and an achievement motivation test to all the grade 9 students. Here he is administering two types of test. One is intelligence test and another one is achievement motivation test to all the 9 standard students. Then on the basis of the scores, students are classified into 4 groups. Which are the 4 groups? High intelligence and high motivation group, high intelligence and low motivation group, low intelligence and high motivation group, low intelligence and low motivation groups. Students from each group is again divided into 3. Why he is dividing again into 3? Because there are 3 types of teaching method. One group he is giving lecture method, second group demonstration method, and third group discussion method. Here we can see different factors at different level so as to find out the effect of each factor separately and conjointly. Here we can see the effect of each factor separately and in combination. There are other questions also from this area, that is differentiate quasi-experimental design from true experimental design and illustrate one example of true experimental design. So from this true experimental design topic, any example you can select, but you have to add like what is quasi experimental design and how it is different from true experimental design. So let us discuss that part also here. Like the true experimental design, a quasi-experimental design aims to establish a cause and effect relationship between an independent and dependent variable. So same, the function is same, but what is the difference here? However, unlike a true experimental design, quasi-experimental design does not rely on random assignment. Here, the researcher is not selecting the subject randomly, cannot do random selection. That is the difference between the quasi-experimental design and true experimental design. Then quasi-experimental design is a useful tool in situation where true experiment cannot be used due to ethical and practical reason. Due to ethical reason, maybe we cannot continue or we cannot repeat one treatment, or some practical reason also we cannot conduct true experimental design. In that situation, we can use a quasi-experimental design. Now let us see the difference of true experimental design and quasi-experimental design in a table. In the case of true experimental design, the researcher is selecting the subject randomly. But in the case of quasi-experimental design, the random selection is not there. Then researcher design the treatment. Here in the true experimental design, usually the researcher himself is designing the treatment, what type of treatment he wanted to give. For example, the teaching method, special method he wanted to give, he will decide and he will design the treatment. But in the case of quasi-experimental design, researcher does not have control on the treatment and he study the pre-existing groups received different treatments. Whatever pre-existing group is there, he is just doing the study there. Then in the case of true experimental design, keep control and treatment group. There are both the groups, control group and treatment group. But in the case of quasi-experimental group, control groups are not required. Let us see an example. Few psychotherapists in a clinic decided to try out a new therapy, but others who treat the similar patients have decided to stick with the normal protocol. You can use this pre-existing group to study the symptoms progression of the patient treated with the new therapy versus those receiving the standard course of treatment. So here the researcher, he cannot randomly select the subject. Whatever subject is available in the clinic, he can select only that subjects. And on the treatment also, he doesn't have that much of control as in the case of true experimental design. So these are the difference between quasi experimental design and true experimental design.